All right. Thanks everyone for joining today's webinar, and also thank you, Dominik, for to meet you again here as a Sencha MVP. My name is Emerson Januario, and I am Sencha Developer Advocate at Sencha, and it's a pleasure to meet you today. Thanks a lot. So it's our time, Dominic. So welcome again, and we are going to today to learn how to consume external UI libraries using Sencha Ext JS products. It's our time, Dominic. Thank you.
All right, cool. Thanks very much. Just wanted to confirm if you see my screen. I'm gonna jump between the presentation and my editor and the browser as well, so we can look at the examples actually. Basically, what you're gonna see is also in a GitHub project, so you'll be able to review it, play with it, and perhaps use it in your projects if you find it interesting. All right, let's start with a quick intro. What we're going to talk today. So I'll talk a few seconds about myself. Then I'll mention about the libraries we're going to explore. Obviously, not every single library that you saw on the first screen, but some of them. And then I'll talk about bringing them in and also consuming them within an Ext JS project. We'll see a few different ways of both linking the libraries and then using them as the UI components. And I try to walk you through a few examples that you might find interesting, perhaps in your everyday's work. Stuff like Google Maps or Leaflet or OpenLayers. Maybe we'll have enough time to have a look at Street View or ckeditor, stuff like that. Okay, so a couple of words about myself. I'm a .NET dev basically, but I did some UIs as well. Started with Ext JS ages ago, I think, and I mostly specialized in WebGIS up to now. So GIS is Geographic Information Systems, so WebGIS is pretty much down to map-based web applications. I now do a lot in GovTech, especially in taxes, but maps are still my kind of like hobby. So I think it will do for the introduction. So let's jump into the actual examples. Okay, so when it comes to mapping libraries, you've got quite a few to pick from. The stuff I work with is mostly OpenLayers, and this is because it's compliance with the OGC standards. OGC stands for Open Geospatial Consortium, are the fullest, so you can consume services like WebMap service or Web Feature service and the like. But obviously there are some other libraries that you can use. A lightweight library called Leaflet, a very nice and really easy to use. Also libraries like Google Maps, you must have heard of it, obviously Bing Maps here. Also Mapbox is very popular, and the libraries I mentioned at the end, they are kind of like complete services. So you don't only get the map library to display a map, of course, but you also get services like geocoding to looking up the addresses. You get the routing services as well, so you can calculate routes for your vehicles, and you can get much more out of them. But basically what they've got in common is they do operate on a map, so you display spatial information with the map background in behind, right? Now, before you're able to work with a library, obviously you've got to bring it in. The most common way of bringing in a library is via script in head, and I think everyone did that. That's kind of obvious. Modern JavaScript also lets you use stuff like require, and you can dynamically load libraries. You can install them with npm and then just simply link them. And I'll show you a little example based on the Ext JS documentation, just to make it kind of complete. And also the approach I sometimes use approach using a callback to Ext function. I use it because sometimes when you publish your code in packages, you should, or you must, or you want to rely on a particular version of a library. So you can bring in your own scripts and link them, or you can link a script from a CDN and just enforce a particular version of such script. As I mentioned, I'm going to be jumping between a presentation and my editor and the example applications. So let me quickly jump to the editor. I'll start with a quick explanation of how the project is structured, so you can use it later if you want. So basically, this is a standard template. This is classic modern desktop, or kind of adjusted classic modern template. You've got the desktop application and it uses classic toolkit, and you've got also the phone application which uses modern toolkit. They are both structured pretty much the same, so just a main view that brings in components, obviously the application as a starting point, and I'll show you how it looks in a little while. Just as a disclaimer, all the examples are simplistic, and this is obviously on purpose. I just wanted to highlight the particular areas of the code, not to clutter it with too much logic that might not be really necessary to understand what's going on. So basically, the application is mainly made of ready-to-use components. There is no logic within the application itself. It just brings in together the UI. Will mostly work with the classic toolkit and the application components put in the into the tab panel. Okay. When it comes to the examples themselves, they are all kind of listed here under view examples, and we'll be walking them one by one. So let's start with the require example, just to recap what the Ext JS documentation shows. Whenever you want to bring in a library this way, you would go to npm install. Then what's required is the app.js file. Sorry, not app.js. Sorry, that's index.js, of course. You've got to edit index.js file, and you've got to require a library like this. And when you do so, you can get the access to that library by simply exploring the actual namespace you require the library under, right? So in this very example, you've got the moment library, and it will format the current date. And when you launch the examples, what you see is the actual okay, the actual application, and what it does, it simply displays a formatted date. When you explore the phone application, it will actually do the same. I'm using the carousel layout here, so it's kind of tabular, but a bit different. Okay, so that's the simplest example I've got here. And I guess this is self-explanatory and doesn't really require more than that. Okay, we've got the head link view, which brings a library linked through the head. So once again, I'm going to jump to the index HTML. This is the library linked. So in this case, I'm talking about leaflet. As you see, I'm going to bring some more tools via head as well. Simply because this is the easiest approach really for the demonstration purposes. Okay, so obviously for leaflet you may need some CSS and then JS, and this is pretty much what happens here. So first comes the CSS file, and then the JavaScript library. When it comes to displaying it, what you usually have to do when linking the libraries is you've got to give it some sort of hosting place in your application. I'm gonna mix a couple of slides here because rendering UIs comes a bit later, but obviously I won't be able to show you a leaflet example without showing how it's brought into the project. So what happens here is I simply, not really sure if you see the webinar tools here, and I'll try to hide them. What you've got to do is you've got to declare a body for the container. In this case, I'm using pure HTML. But also what I have to do is to give it another identifier, because the library later on uses identifier to render itself into it. Okay, so this example simply initializes leaflet map by looking up the actual div container that is rendered to the page, and then sets up an OpenStreetMap layer just to show it actually works. Okay, so to see it in action, what we do is, or what you do when you want to explore the examples, you simply slide to another view, click render map, and what you get here is a leaflet map that can be zoomed in and actually interacted with. You surely see that with the carousel layout, you would have to suspend some events, swallow them, and not pass them onto the layout. This is surely doable, but for the sake of this presentation, I'm not doing that. Pretty much the same situation with the desktop application with Classic Toolkit. We render the map, and the map is operational. It's actually ready to use, so you can potentially create your business logic around it. Another example I've got is the actual Ext-define callback approach I mentioned. So once again, for the map container, I'm using a div component with the proper identifier I can refer to. And then for the map launch, we've got a few steps here. The first, what happens is bringing in the actual script. This happens in the callback, so this is that part. So whenever the actual class is defined, then Google Maps link function executes. I'm pulling here my API key. You will have to create your own API keys JSON file and put your Gmaps key inside. And when you do that, obviously the application will bring in your API key. And I'm linking the actual script customized to use a particular API key. So as you see, I'm using a loader here. I'm not gonna dive into the loader itself. It's worth mentioning that it's based on some Ext JS forum resources. It is just adapted to import CSS and JavaScript files. You can use it, of course. So once I've got the Google Maps API brought in, I can initialize the map. And once again, I'm actually using a trigger fired by a clicked button. This example is going to be pretty much the same. Okay, the main difference is going to be the Google Maps. This time we've got Google Maps, and the previous example used Leaflet instead. So those are the pretty much three standard approaches I use. So just to recap, npm install and then require head, which I use very often, and obviously that Ext-define callback function. Okay, up to now we had some simplistic stuff, but perhaps when you work with external UIs or in any other libraries, you're interested in reusing the components. So let's try to go through that path just to see if you are able to create a component that is going to be reusable between modern and classic toolkits, and obviously reusable in perhaps simultaneous views and alike. let me quickly jump to the presentation as well. So we walked through the linking of the libraries. Now we'll give a shot to rendering them again in the UIs. You've seen the approach with the HTML declared for a component, and let's try to do it dynamically, so you don't have to declare divs and you are free from using particular identifiers that you have to refer to. Okay, so let's try to render the application to the body of a component. As you see, this time the UI itself doesn't really declare any HTML. The base class is Ext JS panel, and the target of this exercise is to dynamically render an external UI to a panel whenever it's possible. Okay, so what happens here is the event wire up procedure, and because classic toolkit uses slightly different events than modern toolkit, we've got to take care of this scenario and just customize the initialization of the component in order to handle that. Okay, so with classic toolkit, the standard event that I use is a render event. What's important, it fires only once. And this is handy, right? Because if you want to initialize an external UI, an event that happens only once is actually what you're looking for. Sometimes, though, the timing goes bad, and after the actual render, you may not have the proper sizing of components, and you might be actually looking for something that happens a bit later. In such case, I would go for after layout. But you've got to remember the after layout fires every time, obviously, the UI or the particular view is laid out on the screen. So if you want to control the library initialization procedure, you've got to fire this event once. The same applies to the modern toolkit and the painted event. This is the closest event to either render or after layout of the classic toolkit, but it also fires many times. So in order to initialize the application, the external library once, you've got to force the single execution of that callback. Otherwise, the initialization procedure will happen over and over again. As you saw, the identifier within HTML is quite often used because you've got to find the particular HTML element in the page so the library can render to. So as a handler of the painted and render event, I'm using something that I call init hosting container. What I do here, I'm generating a custom identifier, and obviously I'm trying to inject the HTML I used to declare by hand in the view component. I do it simply by finding the body element of the sender. In this case, this is Ext panel. And obviously, as you see, it slightly differs between the toolkits. It's body in the classic toolkit and body element in the modern toolkit. I'm diving into the inner HTML, and I just render my div to host the external UI. Once I'm ready with that, I create the map. And in this case, my map is going to be an OpenLayers map. So the component initializes this way. And what happens here, just to give you a quick walkthrough, I'm creating an OpenLayers map. I'm adding a tile layer to it, and I'm using the OpenStreetMap data source for the tile layer. So the OpenStreetMap is going to be displayed. I specify the target. So in this case, this is the identifier of an HTML element, and this way OpenLayers library knows where to render to. Okay, and also I'm setting up some controls. So I'm using attribution control and also scale line and mouse position and things like that. And I guess you're likely to notice the debug tags here. I quite often use the mouse position with the longitude latitude readout just to be able to quickly check what are the coordinates. This helps when you work with spatial data you want to orient yourself in a numeric way. The final declaration is the view for the map. In this case, I am specifying the coordinates and the zoom. You may notice the coordinates are not in longitude, latitude. This is because the standard projection of a sleepy map, and this applies to pretty much every provider, be it Google Maps, Leaflet, Mapbox, etc. They all use spherical Mercator, also known as Google Maps projection. I don't think it's really sensible to dive into the details, but it's worth just highlighting that the coordinates here are in the spherical Mercator, so Google projection. Okay, and this is pretty much it. I also wire up the resize event, so I'm able, and this happened just above, and this way I'm able to update the component sizing after the actual layout change. So let's see that working. And I think my mouse just died, so I'm gonna use my touchpad. Okay. Render to body, and this is what actually happened. This is my coordinates readout in the top right corner. This is my attribution component of the OpenLayers, and also my scale line. As you see, this is the standard OpenLayers map, or maybe you haven't had a chance to work with it, but anyway, this is a standard OpenLayers map, and you can interact with it freely. So I guess we've got something like a pretty reusable component right now. So let's see if we can customize it further and make it work with different settings and customized settings. I'm gonna jump to my next example here. And we've got the reusable component. When you analyze the text, you'll see that I'm inheriting from my previous example here. So I'll be only customizing bits and pieces that change between the components. So the first thing you may notice is actually the config here. So I am able to pass some configuration to the component, and I'm able to read it. And in this case, I'm declaring some default values that are going to be used upon the component initialization. Let's see what happens here. So you may have noticed that in the previous example, the final step of the component initialization was firing an event, and this event was passing the created map object. This is OpenLayers map object. So I am able to observe that scenario and grab this object whenever the event actually fired. And what I do is actually I'm doing exactly this. I am creating a new object with new logic, and I want to hook up into the map created event. And within that event, what I want to do is I want to customize the map initial position and map zoom. Obviously, what you see is retrieval of the options from this is the standard Ext JS way of getting the configurations. And also I'm passing the information onto the map component, and that projection transformation here is actually transforming longitude and latitude coordinates from the standard GPS readout longitude latitude into the Google Maps projection, so-called PSG 3857. I am also setting the zoom. So let's see if it actually works. I'm gonna jump back to my main view so we can actually observe it. And this is an example. So as you see, my basic example rendered somewhere in Warsaw. This is in Poland. When I jump to the reusable map component with custom configuration, I am actually zooming to Greenwich Park, and the map should have centered on the Greenwich Observatory. So this is a customized component, and you can do it from different places in your code. Right, so we've got a customized component now. So let's see if we can move it further. Okay, the presentation invitation also includes the Cesium library, and let's give it a shot now. Cesium library is a library that lets you display a 3D globe similar to Google Earth, but obviously not using the Google APIs, but customized Cesium APIs. Just a side note, you can do quite a lot with Cesium. I'm just focusing here on bringing it in and showing the switch between flat 2-dimensional map and 3D globe, so you can get a grasp of what you can do with maps, basically. Okay, so let's jump over to the example now. And we've got the 3D map component. And once again, I am inheriting from my previous example, and I'm customizing some stuff with different zoom. And I'm also adding a toolbar. So as you see, the customization is not very broad. It actually adds some little bit and pieces just to highlight the evolution of a component we're working with. So what happens in the controller, again, just to keep the example to the minimum, I am trying to wire up the 3D view, and this happens as a callback of a button. So whenever the button is tapped or clicked, the application will render a 3D globe in place of a 2D map, and obviously it can switch back and forth. So let's give it a shot and see how it works in action. Okay, we've got that 3D component. So the component is pretty much the same to the one we saw before. It adds the toolbar and the button. Okay, and this is what happened here. So you're able to play with the 3D globe. You can navigate it. You can zoom in, zoom out. It's a bit difficult. Okay, my mouse started working again, so this is how it works. And obviously you can switch back, and you see the interaction between the map and the globe itself. So when you move somewhere else, well, let's say India, obviously you can toggle 3D or map, and the interaction between components is maintained. Now, just another example of side-by-side components, because so far we've seen only a single component at once. But what you can do, once you've got that encapsulation we get with the properly structured components, is you can display them side by side, and they should not interfere really. So we are going to see that example in a second, and then I move on to showing you a few more examples based on what we saw until now. Okay, so side-by-side examples, and this is what happens. This is my map, so I've got map component, and I've got also my 3D component, and the component on the right-hand side inherits from the component on the left-hand side, and obviously they are, in this case, independent. I could wire the map together, obviously, because they both propagate their internals, like map in this case. And if you wanted to, you could use a message bus, an internal message bus, just to let the changes from one component propagate to another component, and maybe sync them if you wanted to. This is just a proof of concept, so you've got many components that can reside by each other and don't really cause any problems, just work seamlessly together. Okay, there is still some time, I guess, so I've got 3 more examples. They might be familiar to you. I'm gonna show you Google Street View, also Panellum. If you haven't heard of that one, this is the panorama rendering engine, and also ckeditor as a proof of bringing in non-mapping component into the Ext JS panel. Okay, so let's jump to the basic component I'm gonna inherit the 3 others from. Okay, so the basic component is just a panel with the fit layout, and this is pretty much in terms of the basic layout that is going to be utilized. In the controller, I'm setting up some infrastructure for reusing the internal logic, like rendering the containers and so on. And as you see, I am just stealing some code from the examples presented before. So once again, for the classic toolkit, I am using the render event. For the modern toolkit, I'm hooking up to the painted event, but I enforce a single execution of the callback. And I then init the hosting container. So once again, generating a customized unique identifier, and then just injecting the HTML for the hosting container, so it can also be customized. So the basic container is a simple div with customized ID, and it should shrink to 100% of the height and width of the component. And I also provide some custom calls here. So I'm leaving the create UI, for example, for further customization. Okay, so let's start with the street view component. It gets some configuration, so the center, latitude, and longitude. So you're able to put it somewhere where you want, and you can do it by simply adding the coordinates, so you can customize it to your need. The component itself is rather easy. As you see, I'm not really touching the create UI or view resize functions. I don't have to override them. In this case, the container for the hosted UI component is not a div, it's an iframe in this case. And I am passing the actual source for that iframe, so it can render itself, in this case using Google Maps embedded API for the street view. I guess the code is actually quite simple. As you see, it doesn't happen. I mean, nothing serious happens here. So let's see how it behaves when you put it together and want to display that in the UI. So that's my street view example. Okay. There we go. And once again, you get the Google Street View example up and running. You can zoom it, you can navigate it. It will behave exactly as Street View does. And this way, for example, in your application, let's say you're working with some external advertisement, you can, for example, check up billboards, things like that. Just give some information to your users on what's going on outside. I'm gonna use the another example, which is panellum in this case, and once again, let's see how it works before I show you an example. So I am inheriting here from the same component again, so adding some customizations. In this case, I would like to enforce a standardized URI for the panorama view, and I would also like to be able to specify whether the panorama view should load automatically or it should be postponed and executed by the user whenever it's required. So as you see, a simple customization, and also the logic here is very simple as well. Panellum API also uses iframes, so you can inject all the logic using iframe and obviously customize the URL. In this case, autoload is just customizing the autoload parameter of the URL, and I'm injecting a simple iframe. In this case, though, just to prove the idea of components being reusable and independent, what I'm doing is I am adding the horizontal box view here, and I'm showing two panoramas. One should display one panorama with auto load, and the other one should display the other one, but it shouldn't load automatically. And let's see if it actually works. So let's go back to the code again and jump to the panorama view. Okay, this is the first one. So we've got some nice space observatory here. And as you see, the panorama loaded automatically, and the other one configured not to load automatically, simply requires user interaction and also displays independent panorama. And I've got the last example for you. I'm gonna start with the UI presentation, and then I'll walk you through the code example just to finalize the presentation. So this example shows the ckeditor. This is the basic ckeditor script linked from the CDN. Obviously, if you want to use some more tools or paid tools, you can generate your own ckeditor script. You can customize it, and you can then configure the ckeditor itself to show the tools in proper order. And I'll show you that in a little second. So the first thing to demonstrate is just to do some HTML. Okay, we've got the standard editor behavior. Let me add the table, add some stuff into it. But so far, what you see is just the editor itself. Okay, so what happens next? What would be a required behavior in your scenario? Well, I guess you would like to be able to get the HTML of that component, and obviously that's possible. When you do that, it is possible to output the actual HTML that has been put into that component. But also, I guess, if you were thinking about an editor that is able to both create content and then modify content, you should be able to bring the content in. So this is, of course, possible, and it's quite simple. You can do it like this, and you can bring in some own HTML you can interact with. And obviously, when you dump it again, sorry, that's not the one. That's the button. As you see, the HTML got customized, and actually the other HTML has been output to the console. So let's have a quick look how it works when it comes to the ckeditor view. And I think that's going to be the final part of the presentation, but let's see it first. So once again, nothing special here. I am inheriting from my base view component, customizing the title and adding my toolbar. In this case, this is a bottom bar, and I want to add the set and get functionality to that component. And then let's see what happens when you want to instantiate it. So in this particular scenario, I am adjusting something. So when I'm trying to init the hosting container, I am also creating a UI, but perhaps, as you see, I'm not using the identifier anymore. I am hooking exactly straight to the body element, and I'm passing the actual DOM element to the classic editor. This is what happens here. So when you initialize ck classic editor, you pass it the actual element, not the identifier. Obviously, you could get that element by ID. That's not a problem, but this example just proves that you can do it in different ways. So the editor gets customized. Some of those tools you see here are not available for this particular build of the ckeditor. And obviously, when you execute that example, you will see some warnings that particular tools are not present. But as I mentioned, you can generate your own ckeditor script, and you can bring in your customized toolset in. So you specify the tools you want to use for your ckeditor, and then you can customize some stuff further. You can add another toolbars. You can add another toolbar with the tables. You can customize the link behavior. You can grab the actual instance of the ckeditor upon its creation, and this is what I'm doing here. So I am able to refer to that editor a bit later. So whenever the editor instance gets created, I get a callback. I'm grabbing the instance, persisting it for the further usage, so I can interact with it freely. And I think this is the end of what I've got to show for today. So obviously, when you've got some questions or you would like to discuss some stuff further, please free to do so. As I mentioned, if you jump over to github.com Cartomatic and you query for the Ext JS examples, you will find this project. You'll find some other projects as well, some much older, some not. Feel free to use them at your convenience. Also, when you jump to cartoninjas.net, you may find some more information. A little disclaimer though, this blog is during a migration, so it just tells hello world at this stage, but it should come back online in a few days. And you should be able to find some other Ext JS examples there amongst the others. Okay, so this is all from myself for now. Q&A if you've got some questions to ask.
All right, Dominik, thank you very much for your amazing presentation. This is huge. In this presentation, you teach many things, interesting things, professional things inside Sencha JS ecosystem. You present how to use external libraries using the Ext JS. You also explore a lot how find custom events from components using controller and view model and MVVM. So this is not only consuming external tools, but you teach many good things. And to get started with our question and answer session, we have the most questions. The most asked question here is if the source code will be available. So you are sharing the screen. So guys, if you'd like to see how everything was made by Dominik, please enter this URL on GitHub, and you're going to see everything how this work. And we have the Dominik email here. If you have any question, you can connect with him. We have another question here, Dominik. What are the most common mapping libraries?
I kind of already talked about it at the beginning. It actually depends on what you are after. Google Maps is very common, obviously. I find Mapbox very useful. It gives you quite a lot. It gives you nice vector rendering abilities, obviously routing, stuff like that. And you can also create mobile libraries with it. As I mentioned, in the WebGIS world, so a bit more, let's say, geomatic world, OpenLayers is very popular. It is also a very good library. I guess it may require a bit more knowledge from the GIS field, but I like it a lot indeed. So if I were to number it, I would obviously start with OpenLayers, but maybe in other words, any library that does the trick for you is good for you. So I wouldn't really focus on a single one.
Got it. Good. I can combine one more other question here. Are there any advantage or disadvantage of using any of them? I know you have presented many kind of libraries, but the question is, are there any advantage or disadvantage of using of them?
Again, I think I base my answer on the actual requirements. If you just want to show stuff like base map and I guess maybe some place marks, Leaflet is an excellent choice. it's lightweight, quick, and it also can consume some data in vector formats like vector tiles, and it can style them nicely. If you want to consume some publicly available services like official Gov services, as I mentioned, some of them, something like Web Map Service or Web Feature Service, then I guess OpenLayers would be your library of choice. If you want to utilize stuff like routing, geocoder, any APIs like address search, stuff like that, I guess any of Microsoft Bing, Google Maps here, or Mapbox would actually make you happy. So whatever works best for you is the best choice, I guess.
Got it. All right. Another question here. Is it possible to mix the libraries and use their specific functionalities where required?
Obviously, and I hope I did demonstrate it in this presentation. So let's say Google Maps and Street View. I'm gonna quickly jump to my editor here just to show you how it may work. So well, let's say you wanted to use Street View with your other component. So I guess you could do it like this. We had reusable map component. This is OpenLayers, and I guess if you wanted to pick up a click from the map and say wanted to display your Street View in a window, okay, I guess you could do something like this. So let's say I'm gonna quickly type it just to prove my point. Hopefully you won't get bored. Sorry for the order of the parameters, or let's say 500 and the height 500, and I hope this will answer the question. So I think I had it complete. Yeah, so let's finalize it. If I didn't make any mistakes, it should work. So let's see if I'm lucky enough. As with everything, live coding is something that sometimes likes to fire straight into your face. So basically, one component here and the other one totally different on the top of it. So yes, it is possible to use them.
Good.
Together.
So you can mix everything. If you have the coordinations, you can use both. All right. Another question here. I use Google Maps. Why would I want to use anything else?
If you were to consume data provided to you in a format that is not easily consumable on Google Maps, then I guess that would be a good reason to think about a different mapping library. Let's say that you want to show some flood areas. Let's say you work for an insurance company and you want to calculate the premium for particular areas, and you want to visualize them on maps. So you see if a certain building actually should pay, or an owner of that building should pay premium because he put that building in an area that gets flooded from time to time. That's one of the examples you would actually look after other libraries. Or you could obviously think of transforming one service into another one, but that's a totally different part of the story.
Good. Another question here about testing. How you will approach it? Do you make some testing? Do you have something to share about testing while using this kind of maps or external tools?
So I usually don't test the external libraries because obviously I kind of assume they are already well tested. What I do test though is the internal logic of mine. So if I've got some procedures that calculate, let's say, coordinates or do some transformations or prepare the particular data fields or data payloads, then yes, I would test them. But I think I would go for the unit testing approach in this case. If there is enough time for the project and the budget allows it, I would also do some automated UI tests. In this case, I mostly use Selenium, but I guess you could use any other library. But basically, I tend to not test the libraries themselves, just letting their creators do that. I just test my customized logic for the correctness of its operations.
Awesome. You mentioned using package at the beginning. So do you have an example of how to implement the three different methods of using an external library in relation to using packages? Am I clear with the question?
Yeah, well, you could create an npm package, obviously. That's not a part of this presentation, but you could also create a simple package Sencha way. And such a package can be linked remotely or it can be linked locally. In many cases, I mean, when you look at the code I showed, obviously the npm tooling lets you create a shared space for the packages, or maybe shared code. That's a better description of it. And then depending on the toolkit you want to generate the application for, you can consume that. But if this is not enough and you want to share it between, say, different projects, what I usually do is I create the Ext JS package and I put it in an independent repository and then bring it in, usually by symlinking the folder under the packages local and then consuming the shared code this way. That's the most, I think that I do it the most often.
Yes. Now I have one comment from my side. I have seen you share it at the beginning. You are using open tooling, right? So you
Yes,
can
for this example.
so this is very good to use open tooling because you can use node package in your EXJS application easily, right? So if you'd like to share your screen where you and just open the index.js file, maybe this is good for everyone, for those who are not using npm and open tooling, for those who are using still cmd based application. So we have one documentation in our EXJS doc. So I am talking about the index.js file when you require the moment library, for example.
Yeah,
So
that's the example.
would you like to do to do some tips for those who does not know about this feature yet? How important, how useful you can use the index file in short 1 minute, please.
Yeah, well, what you actually do in this case, you would go for the npm install. So obviously, if you were to repeat that, you would go npm install moment. I've got that library already, so it won't actually install unless there is a fresh version. So let's see what happens. So that's the standard approach. You just install the application. Well, it actually says that it's updated something, so I guess I might have some other version of moment library. But anyway, npm install, that's the first step. Once you've got that installed, you require it in the index.js. That's the Sencha way of bringing in npm packages. And this is the way it is. You use the application namespace, although this is the default content of the index.js generated by the generate application. But you can use your application namespace. You just put some variable there, and then the require output is assigned to it. And once you've got it, obviously, when you use Webpack and you debug it the standard way, you just use it like this. So let me hide that one. So you just refer to the variable location you declared before, and you call an external library. There is a nice intro in the Ext JS documentation for it as well, so it is worth inspecting. But although I use the NPM tooling for this presentation, I still maintain some older XJS projects that that are not yet migrated to the newest tooling. So linking the libraries via head or by other means, it is still a viable option for me.
Awesome. Congratulations, Dominik, for your good presentation, and thanks for your answering all the questions. So it looks like we have answered all the questions asked at this time. So guys, stay tuned for our upcoming webinars. I would like to remind everyone that today's webinars was recorded, and we will be receiving a follow-up email with a link to the recording shortly. So once again, thank you for attending today's webinar, and we look forward to having you join to the next time. Thank you, everyone. Thank you, Dominik.
Cool. Take care, guys. Take care. Bye-bye.
Bye-bye.